Hey guys, today I'm going to show you how you can build the binary search tree in Java. So I just went in and they started this just for the sake of saving time. So what we just started a class name BSC binary search tree. It's going to be of type string, and we are going to extend this comparable interface that is provided by Java. It just allows us to compare two elements. It's very useful. You should check it out. That it's basically just an interface that allows us to compare two elements and we return the value either positive, negative, or equal to 0, depending on how the comparison is. I also went in and wrote something here as a definition. So binary search tree, it's a binary tree with symmetric order. And the binary search tree can be either empty or disjointed binary trees in the left and right. Every node has a key, and every node key is larger than all the keys to its left and smaller than all the keys to its right. These are very important definitions that you are going to, I'm going to show you why I wrote that there and how is important for us. All right, so let's start. So to do that, so the first thing we need to do is, for anything related to building a data structure with nodes, we need a private class called node, because the binary tree is effectively made of nodes. So what do we need? We need basically a key and a value. So we're just gonna do them string, but they can be anything really. But I'm just gonna do them with strings, of type string this time. But you can have them in integer. You can have them in any other data type you would like. So string key and then string value. So now that we have a key and a value, we need a left and a right node. So we're gonna do that. So let's keep all of them private. Node, it's gonna be left, and then it's gonna be right. Let's just do them in two things. So private node, and it's gonna be right. So we have key value, left node, right node. And then let's just do a constructor here, public node. Let's make sure that our constructor will take in key and a value. So key and then string value. Let's assign this element in. We want the key actually. Key equal key, and then this that value equal value. All right, so this is all what's to this inner class really. So all it has to do is so it's a node, and every node in our binary search tree is going to be of this type. So node can have a key and a value, and the left node and right node. And then a constructor which we're going to call in if we want to construct a node. We have to pass in a key and a value to construct the particular node. So this is basically the built-in block of our binary tree. So let's start building the binary tree. So to build the binary tree, the first thing we need a root, which is the first node. It's going to be the first node in our tree. So we're going to call it root, because it's the root of the tree. So we need two functions really. A function called put, which will allow us to add nodes to the tree, and a node called get, which will allow us to get nodes from the tree. So let's add it. So let's do public void put. This function will just allow us to add basically nodes to the tree. To add it, what you need to do is basically you send us a key and a value, and we try to add that node to the tree. So to do that, we will create another function, because this key is just public. We need another private function to do that. All right, so root is going to be called put, but then we'll have to pass in the node. Having to pass in the root to it, and then a key and a value. let's create that function. So what will happen here is basically every time you would like to add a node to the tree, you pass in a key and a value, and once you pass in the key and a value, we're trying to add that node to the root. In order for the tree to do that, you will need another function, basically that you're gonna pass in the root to and the key and value, and basically we are gonna kind of traverse. Think of it as traversing the tree until you find the right location for that node and add it to your tree. So to do that, so the first thing you need to do, you need to check if your node is null. So what would you do if our nodes is null? That means this is the first node we received. So we are going to basically just create the first node. And this is all it has to do. We pass in a key and a value to it. New node, key value. Yeah, it looks like we didn't do this correctly. So key value. Why is complaining about this? Why is complaining about this? Node, why is complaining about this? This is the key. It has to be in here. Yeah, not sure why it was being doing like that, but it shouldn't be complaining. So the first thing we did is basically we create a node, and we basically just invoke this constructor, and they'll form the new a new node. So this is in the case where we have basically this is the first node in the tree. Now that it is, in case it is not the first case in tree, so we have to traverse the tree and find the right location for that node. To do that, we are going to use, as we talked earlier, we are going to use this interface comparable. So let's do that. So we're going to do, we're going to check if our key that we passed in, so we're going to compare our key I am not certainly sure why this key is, because I think it did, yeah. So we just do key, yeah, key.compare, and then we are going to compare it to the key of the node. So we're going to compare the key that we have, which is passing in, to the key of the node that we have. And based on that key, as we said here, so we're gonna base this on this definition. So every node, every node's key is larger than all the keys to its left and smaller to all the keys to its right. So and this comparable, if you go in here to this, you're gonna see that either gonna return us a negative value, a 0, or a positive value. So a negative value means less than, a 0 mean equal, and a greater value, positive means it's a greater value. So to do that, now all we have to do is we basically gonna evaluate this. So after evaluation, we're gonna say if comparison is less than 0, so what we need to do now is we have to go left, right? Because it's smaller, you have to go left. So, and then you just recursively keep going left, basically. Key that left, and then this is key, and this is value, right? Just based on the definition here, because every node is larger than all the key to its left and smaller than the key to its right. If it is not smaller, so which means if it is bigger, so what we're gonna do is if this is bigger, than 0, so we have to go right. So we're going to do x stat right, and that's going to equal put and then going to be, we have to keep going right. So basically it's like traversing the tree. So you are either gonna keep going right or left based on that, based on this evaluation, right? So we're gonna evaluate the incoming key with our node, with our root node. So we're gonna start from the root, and we're gonna keep going. If it is smaller, you go left. If it is larger, you go right. And then if it is equal to 0, I mean, we found it. So else if, so if it is equal to 0, that means we found it, and then we just put our value in there. So that is, and then we return the node, because that would be, so we return the node. So this is very simple. We just basically think of this as you are traversing the tree, and then you are comparing the element you got to as you traverse the tree to the nodes you are going through, and you keep going left if it is less, you're going right if it is bigger, and then once you found the value, you just assign the value to basically to the node. Now, after adding the node, we need to retrieve a node if we would like to search the basically binary search tree. You have to retrieve the node. To do that, what you can do, we're gonna create a function called, so because our values are in string, we're gonna do this string, public string. We're gonna get, so if we would like to retrieve a value, let's do that. Sorry, so if somebody want to retrieve a string. So the first thing, we are going to start from the node. We're going to start from the root. So we started from the root, and then we're gonna start traversing through the tree. So as long as the root is different than null, what we'll be doing is basically comparing, using the same interface we talked about earlier. This is a Java interface. This is a built-in Java interface. You can, it is in Java9 package. You should use it. It just compares. It's just a very handy interface that we can use. So if the comparison, it's gonna return a value in here. So we're gonna compare the key to our root, and then it's gonna return either a positive, negative, or a 0, depending whether it is bigger, smaller, or equal. And we are gonna keep traversing the tree. So let's say, so if the value of the comparison that we get back is less than 0, as we said earlier, so we have to keep going left. Right, and else if the value is bigger than 0, we'll keep going right, and if it is equal to 0, that means strike, we found it. And then we're going to return that value. And this is all what to it. If we didn't, we're going to return null, which means we didn't find it. So if you want to get a value from your binary tree, you require a key, or when somebody passing a key to you, you start from the root, and you keep going as long as the root is not null. Obviously, if the root is not null, you don't have any nodes, so you return null. But then you compare the key that you got with the node that you are at, and you basically just keep traversing the tree. If the comparison less than 0, you go left. If the comparison is bigger than 0, which is positive, you go right. If it's equal, you strike. You found it, and then you return that value. And basically you keep looping until you run out of nodes to go through. And if you can't find it, you return null. So this is all what it is to the building binary search tree in Java. It's very simple. All you need is an inner class node to form your nodes, and a function to get the node if you are searching a node, because this is effectively a binary search tree. Or if you would like to add nodes to the tree, you need these two functions to add nodes to the tree, and you need this as a private, which is the root of the tree. I hope this is useful to you, and I hope you will find this helpful and useful and help you understand the binary search tree. Thank you.